Let's keep going in section 3.2. The topic is synthetic division. We just learned the division algorithm. It gives us a method to rewrite a polynomial function f of x in the form x minus k times q of x plus r, where q of x represents the quotient and r represents the remainder from the division problem f of x divided by x minus k. Wow, that's a lot. Okay, here's the new question. The new question is, if we can write f of x in this new form, then what does that tell us about f of k? That's a hard question. It's sort of abstract. There are no numbers anywhere in my question, but if we think about it, I bet we can get the right answer. What does f of k mean? Function notation tells us f of k just means that x gets replaced by k. So here's x replaced by k minus k times q of k plus r. And then the interesting thing is k minus k is 0 times q of k plus r. 0 times q of k, well, q of k is kind of abstract, but it doesn't really matter what it is because it's multiplied by 0. And so that's 0 plus r, which is just r. So this is a nice result. It tells us that the remainder from the division gives us f of k. And that fact is called the remainder theorem. It says if f of x is divided by x minus k, then the remainder is f of k. That's a little tricky, so let's go ahead and have an example and see if we can make sense out of this. So let's see, I think we're up to example 4 or 5. Let's call it example 5. And the problem says let f of x equal this polynomial, negative x to the 4th plus 3x squared minus 4x minus 5, and we want to find f of negative 3. So there are two ways to do this. Method number 1 is what you learned a long time ago, which is to plug negative 3 into the function. So you would have f of negative 3 is equal to negative 3 to the 4th plus 3 times negative 3 squared minus 4 times negative 3 minus 5. And I think if we clean that up, we can agree that the answer is negative 47. The big idea now is the new way to do it. The new way to do it is with synthetic division. And so f of x is the dividend. It goes under the house. Write those coefficients out carefully. Negative 1. X to the third is missing, so we'll put in a 0 as a placeholder for x to the third. And then the coefficient on x squared is 3. And then negative 4 times x to the first, and then the constant at the end. All looks good. And then out in front is the value k. Well, negative 3 is going to be our k value. And so what happens if we do this synthetic division? Negative 1 comes down, and then we're going to multiply and add. Multiply and add. Multiply and add. Multiply one more time. 14 times negative 3 is negative 42. And so the remainder is negative 47. Wow. Negative 47 is the answer. The remainder is the function value. The remainder is the function value. F of negative 3 is negative 47. Shall we do one more? Let me show you what the directions are going to look like in your homework. We'll call this example 6. And we'll say, given f of x, use the remainder theorem and synthetic division to find f of k. And in this problem, we'll have f of x is equal to 2x cubed minus 3x squared minus 18. And we'll have k is equal to 2. So what we're trying to do here is we're trying to find f of 2. And we could just plug it into f of x, but we've got a better way now. Let's use synthetic division. Let's put a 2 out in front, and then let's put the coefficients of the polynomial under the house. Let's put in 2, negative 3, 0, and negative 18. Remember that 0 there is for x to the first. Let's go through the synthetic division. 2, 4, 1, 2, 2, 4, negative 14. And there's the answer. F of 2 is equal to the remainder, negative 14.